Hello and welcome to this session on Amazon S3 security and management. My name is PD Datta. I'm a product manager at Amazon S3, and I'll be later joined by Christopher Schultz, a director of software engineering at Capital One. So here's what you should expect from this session. We're going to talk about the basics of Amazon S3 access control mechanisms for the first 5 or 10 minutes. I'm going to set the stage with some examples. Then we're going to talk about Amazon S3 block public access. That's the new feature that we launched a few days ago. We'll go to the console. I'll show you the demo of how these settings work and how you can set them, and some failure use cases. Then we're going to talk about how Amazon S3 or AWS authorizes a request. We're going to switch gears, go into encryption, the different encryption modes that you have in S3. Then I'm going to close with monitoring security in Amazon S3 and hand over the stage to Chris, who's going to talk about how Capital One is using Amazon S3. And he's going to go over 2 use cases. Before I move on, some related sessions that you might want to join. The first one is a leadership session. This is more of a lecture style session, so we will handle questions only at the end. If you would like to have a more Q&A style session, we will have our SDE and myself talking in a chalk talk where we will go deeper into cross-account access tomorrow. All right, let's dive right in. OK, to start with, when you create a new AWS account, or even if you're an existing user, you're probably thinking, how do I best secure my data in S3? And if you're using AWS, it's best practice to exercise least privilege. So when you create an S3 bucket or an object, it's private by default. And the access is only limited to the resource owner who's creating those objects or buckets. And then you slowly grant access to other users and IAM principals. It's always best practice to slowly and granularly grant access to other users than opening up the access and then tightening it after the fact. And doing that requires some research. You probably need to know what permissions I need to have the user, I need to assign to the user, and what permissions I need to assign to the resource. So to do that, we have different access control mechanisms. I've listed them here. We'll go through each of these and then go through some examples on how these can be used. What I need you to know is when you're thinking of security in AWS, there are 2 jobs. The first job is specification, and that's your job. That's the customer's job to specify what permissions need to be assigned to which users or resources. The second job is enforcement. That's our job. Based on the permissions that you've attached, the policies that you've created, we will enforce whether a request is authenticated or authorized. So let's start with IAM. Now, IAM is a service that works across all AWS services that helps you creating authenticated users as well as authorizing requests. So when you think of IAM, you start with a principal. Your root user is your first principal. Now, as a best practice, it's recommended that you don't use root for your applications or your workloads. It's better to create users and give them admin privileges. So any application or AWS service principal, they're all AWS principals. That principal will send a request. A request contains actions that it wants to perform, and it also contains information on which resource it wants to perform that action on. That action needs to be authenticated. So when you sign into your AWS Management Console or you use the CLI, you need to provide your secret key and access key to authenticate a request. When an authenticated request reaches a resource, then it's authorized. So we collect all the policies together, and we authorize that request. Once it's authorized, you can perform that action. Could be create bucket, put object, get object. And since this is an S3 session, I'm using the resource as S3, so you can create a bucket in S3. Or you can put object in an S3 bucket. So that's how you should think of how IAM overall works. Now, we talked about IAM policies. Over here, I'm going to stick to user policies. A user policy is that you attach to a user. So your mental model is, what can this user do? Typically, you should use IAM when you prefer to keep the control in the IAM environment, and it spans across all AWS services. The similarity between an IAM user policy and an S3 bucket policy is that it uses the same JSON language. The difference is the control is on the S3 side when you're writing an S3 bucket policy, and your mental model is who can access my bucket. That's what you're trying to define in the S3 bucket policy. And it also helps you with granting cross-account access. So we'll go through cross-account access in a few slides. So let's take an example. On the left, you see a user policy that is hanging off a particular user. This particular user, which is can do a put object or a get object on my reinvent bucket. On the right-hand side, I have the S3 bucket policy. I've highlighted the PARC, which stands for principal, action, resource, and condition. That's your PARC model when you write a policy. So you can see that the principal has to be defined in the resource policy, which is my bucket policy, whereas this is implicit because it's hanging off the user. That is hanging off the bucket, which is the resource. So in this particular example, this principal is going to do a get object on my reinvent bucket, provided it also satisfies the condition that those objects have a tag called project X. So you're restricting or making your policy stricter with the condition tag. Okay. Next, we're going to discuss ACLS. Access control lists are a precursor to policies that you can hang off a bucket or an object. This is specific to S3. It's much simpler because you need to give a permission, and an ACL needs a grantee. So ACLs can only grant access. You cannot explicitly deny access with ACLs. It's written in XML. You can grant access to predefined groups, such as all users and any authenticated user. So first pro tip is you should use caution when you're using ACLs, especially with these groups, because you're opening up your bucket or your object to the public. There we go. ACLs also give a finite set of permissions. So you can do read, write, full control. Full control is something that you need for cross-account access. And we're going to discuss that when we move to cross-account access in S3. Most of your use cases, bucket policies with object tags, for example, and otherwise, should be able to cover most of your use cases. You should use ACLs only if you're comfortable using ACLs within the S3 environment. The fourth type of access control mechanism is a VPC endpoint policy. So if you can create a VPC so that your traffic does not leave the Amazon network, and you don't have to use internet gateways or NAT gateways to grant access to your bucket. Now, when you create an endpoint, there has to be a policy that allows access. Otherwise, everything is denied. And in the next few slides, we're going to talk about some of the endpoint policy examples that you can use to control access to your S3 bucket through a VPC endpoint. So in the first example, I've created a VPC endpoint, and I want that any traffic that's going through that VPC endpoint should only access my secure bucket. So in this policy, I have defined the resource and attached this policy to a VPC endpoint. Now, say you have a large organization, and you don't want to explicitly grant each user or write a policy that becomes big because you're explicitly listing them here. So if you use AWS organizations, for example, that manages different accounts, you can use the AWS:principal org ID condition. So in this particular policy, what we're doing is I'm allowing a principal star means everyone, but the condition has to be satisfied. The condition says that if you're using principal org, allow only if that principal belongs to my org. So I extended the previous policy with this condition. This policy is hanging off the endpoint. Now, my secure bucket is the resource. So I want to also further, I want only a few these principals coming through a particular endpoint to access my bucket. I don't want anybody else to do that. So in my bucket policy of the my secure bucket, I write a policy where In the condition block, I say only if the traffic or the request comes through this particular endpoint, only then you should grant access. So when you mix both of these examples, it gives you more stricter controls. Okay. And the final one, as we talked about in access control mechanism, is pre-signed URLs. Some of our customers use pre-signed URLs if they don't want to assign any AWS credentials to a lot of developers that they have in their organization. Any IAM user or role can create a pre-signed URL and define what action it can take, such as put object or get object. So if they have the permission, they can sign a URL. Any other user, when they get hold of that URL, can assume that role and then do the action, which is put object or get object. So pre-signed URLs come with an expiration time. Something you should keep in mind is anybody with that URL can assume that role and perform that action. So when using pre-signed URLs, please be careful as to who you are giving that URL to. OK, so we talked about the different access control mechanisms. Let's switch gears and talk about the new feature that we launched a few days ago. It's called Amazon S3 Block Public Access. And let's define public access first, and then we'll move to what Amazon S3 Block Public Access is. So any anonymous or overly permissive access is something that we consider to be public. For example, with ACLS, if you are granting access to all users, which is anybody on the internet, or any authenticated user, which is anybody with an AWS account, we consider that to be a public access. Similarly, in a policy, if you write a policy with principal star, allow principal star, resource star, action star, that's a very powerful policy. You've pretty much opened up access to the public. So that is also considered to be public access. If you have explicitly granted cross-account access, then that is not public access. So S3 Block Public Access is a set of security controls. It's a set of 4 security controls that you can apply to an account or a bucket that overrides the settings that might have granted public access to your bucket and your object. You can do that through the API, the CLI, the SDK, and the console. Now, for example, an administrator can set these settings at the account level and then write an SCP. So if you're using AWS organizations, SCPs or service control policies are permission guardrails that you can put. It's like a front door, and that will deny the action. So you can write an SCP to deny action for anybody to change these settings once you've set them, including the root user. Only your org admin can change the SCP or change the settings after that. So let's go through each of these settings. So the first setting blocks new public ACLs on buckets and objects, and it also prevents anybody from uploading an object that has public ACLs. So you should use this setting for future use cases where you don't want anybody to update an ACL on a bucket or an object, and you don't want other applications, for example, to upload objects that have public ACLs. The second setting removes public access granted through ACLs. So say you have a bucket with 1 million or 1 billion objects, and 2 of those objects have been uploaded by an application or a developer, and they've been made public. So anybody, if you don't have an explicit deny in your policy, anybody can access those objects, and you want to remove that access. So with this setting, for existing objects and for future objects, your public access becomes moot, because we will deny anybody from accessing that object if you don't have it in your policy or ACL. The last 2 settings are about policies. So the third setting blocks new public policies. So we will prevent you from attaching a policy such as principal star, action star, resource star onto your bucket. The fourth setting blocks public and cross-account access if you have public policies. So if you've written a policy where you've explicitly granted access and we don't flag that as public, then if you set this setting, it's going to be fine. However, if you have a policy that has a statement that actually grants public access, we will flag that bucket to be public. And then for the time being, we will remove any cross account or public access and restrict access to only authorized users within that account and AWS service principal. This is an intermediate stage where you can go and your data is protected, and you can go and update your policy and fix it to have explicit access. Now, these are some options that you can see in the console, and we're going to go through the demo, but you can also do it through the API. When you do it through the API is called public access block. It's an XML configuration file that you can either attach to a bucket or you can attach to an account. These are two different endpoints. And the account endpoint is the new endpoint that we introduced with this feature. To get the status, you can do a get public access block. And to remove it, you can do a delete public access block. We also introduced a new API called get bucket policy status, which if you were using the console, you probably saw it in the console, which was the public indicator. Now you can use this particular API to see if your public policy, if your policy has public access or not. From the policy perspective, we use automated reasoning powered by Zelkova to determine if your policy is public or not. So let's go to the demo. Now, in this demo, I have account 1, which is pdata, as the user, and I'm going to use pdata in Chrome and the CLI. And account 2, the user is Arya, and two bucket names that we are going to deal with are no public access and a cross account. So when you go to the S3 console, this is the screen that you will see. You will see a new side navigation bar. Now I'm going to increase the font of this so that folks at the back can also see. So what this says is in the side navigation bar, it says public access settings for this account. Now, when you go now, probably all of these settings will be set to false. Let me go back to my bucket. I'm going to use this bucket where I have this object that is public. So it has public read access. So if I go to a different browser, just to check, yep, I can access it. So let's go and check what the first setting does. So the first setting is to block new public ACLs and uploading public objects. So if I save that, I have to confirm my intent. And then I go back to my bucket. Say somebody tries to make this particular object public. No, I'll get an access denied because we are not going to honor that request. Now, I've set this at the account level. So if you set it at the account level, all the buckets within that account will inherit the property. If you have set it at the account level, you can also set it at the bucket level, but that's a redundant step. And all of these settings are additive. So say I set setting 1 and setting 2 at the account level, and I set setting 3 and 4 at the bucket level. For that particular bucket, it's additive. All the 4 settings will apply. So I'm just going to play around with the account settings at this point. So I'm going to set the second setting as well, which removes public access granted through public ACLs. So I'm going to confirm that. And I've set this at the account level. So this particular bucket had this particular object, panda.jpg, to be public. So let's try and see if we can still access it from a different browser. I'm in Chrome now. No. So even though that object had public ACL, during authorization time, I will remove that public ACL. So there are a couple of things you should keep in mind. Well, I'm going to get access denied. So your public access through that ACL becomes moot. And it also removes the public ACL. So when you do a get ACL, we will remove the public ACL part of this. So this setting is useful. These two settings are useful if you don't use ACLs and you don't want anybody to update your ACL to be public, and you don't want to deal with any objects that might have had public ACLs. Now, you should keep in mind, if your applications were based off of public ACLs, then once you do this, those applications will break. All right, so let's try the third, which is block new public bucket policies. So I'm going to set that at the account level as well. And then I'm going to try and update the bucket policy for this particular bucket with a public policy. So this particular policy is doing action of S3 star and allowing anybody access to this bucket. So if we try to do that, sorry, it's the, yep. Okay. All right, yeah, access denied. So I have prevented anybody from attaching a public policy to my bucket. Let's try out the final setting and see what you can do. So I'm going to remove the third setting because it will prevent me from updating a public policy. Instead, let's see how can I enforce. So once I've done that, I'll go back to this bucket and see what happens if I put a public policy. So in this policy, the first statement grants public access. It's pretty much principal star dot star. And the second statement actually explicitly grants the other user in the other account access. So when I save this policy, the bucket has been flagged as public. If I go back to the first page, the status has been updated as well. So we've restricted access to only authorized users of this account because we flagged that policy to be public. Let's try to get an object from this account. So this is account 1 trying to access account 2's bucket. That bucket has been flagged as public and access has been restricted. So I'm doing a get object and access has been denied. I probably wanted this particular user to access it, but because my policy was not written properly, that right now this user cannot access the bucket. So I'm going to fix the policy by going to the bucket policy tab, and I'm going to remove this statement that grants public access. So now I have explicit access to PD in account 1. So when I do that, you can see that the public indicator is gone. And I'm able to get object from that. So this is the object that I got in this bucket. Yep, it's the picture of a lion. So if you don't have use cases that require public access, such as hosting S3 websites, we recommend that you turn this on at the account level. Once you turn it on at the account level, any existing bucket and any future buckets that you create will inherit those properties. There's one more thing. Through the console, when you try to create a bucket, you will notice that these settings will be turned on by default, and this is only through the console. Now, this is a redundant step if you already have the account level protections in place, but we wanted to ensure that it's intended when you have an intention to make objects or buckets public. Now, this is not through the API. Through the API, you have to manually set these settings as you create a bucket. So it's in the create bucket workflow. Okay, let's talk about how authorization works in S3. When we authorize a request, we actually take all the policies together, object ACLs, bucket policies, endpoint policies, IAM policies together, and evaluate a request. For the simplicity's sake, we're going to go through 4 examples, and I've divided them as user context check, bucket context check, and object context check. So user context check is we check if the parent account has granted this user access. The bucket context check is to check if the bucket owner has allowed this particular user to perform the action. The object context check is we look for an explicit allow if the object ACL grants access or not. So by default, all decisions start at deny. Then we evaluate all the policies together. And as we're doing that, we look for an explicit deny. Is there an explicit deny in the statement? If there is an explicit deny, then another pro tip, it will override all allows. Now, say you don't have an explicit deny, then we look for an explicit allow. Is there an allow in any of the policies for the user to perform an action on the resource? If there is, then the final decision is allow. Otherwise, it goes back to the default decision, which is deny. So it's deny by default. Now we're going to take 4 examples. The first example is, say, PD is a root user with admin privileges. I'm trying to do a bucket operation on a bucket that is owned by my account. When I do that, then we don't do the user check. In the bucket check, we see that PD has root credentials, and if I have given permission for PD to access the bucket and perform like list bucket operation, then the access is granted. If not, the access is denied. What if PD is an IAM user in the same account but does not have root credentials? In that case, I'll check the user check. In the user context, we'll check if the user policy that has been attached to PD allows PD to perform the action of, say, list bucket. If so, since the context authority is the same account, we will do those checks together and authorize that request. If the user policy does not allow PD to perform that action, then we will deny that access. So what happens if PD is a user in account 1 and is trying to do a bucket operation in account 2? Then we have to check both the user policy that is attached to PD. We have to check whether the parent account, so account 1, has allowed PD to perform that list bucket operation in account 2's bucket. In the bucket check context, we will check if account 2 has written a bucket policy that allows PD to do the list bucket in my or account 2's bucket or not. Only when they match, that's when the access is authorized. Otherwise, it's denied. And finally, if there is, so PD is a user in account 1, accessing an object that belongs to account 3, and the bucket belongs to account 2, all the checks we have to evaluate. Does PD have the necessary permissions to do that particular operation? Has the bucket policy or ACL allowed PD to do that operation? And if there is an object in that bucket, is there an explicit allow for that operation? So this is a good segue for cross-account access. So in case of cross-account access, let's take an example. It's going to be a simple example probably you see in data lakes. So say you have account A as a bucket. So account A has written a bucket policy for account B to write objects in the bucket. At this point, account A can only delete that object or deny access to that object, because account A is paying for the storage of that object. Account A cannot read it. Now, this is where ACLs come into picture. So since account B has written that object, account B owns that object. Whoever uploads the object is the object owner. So in this case, I am granting a full control to account A. So with full control, I can have the permissions of reading the object. But say it's a big organization, I have multiple accounts. If I want to grant access to account C and account D, you cannot just write a bucket policy and grant access to objects that you don't own. the bucket policy will apply to objects that account A owns. So there are two ways where you can grant access to account C and account D. Number one would be ACLS. You can update the ACL on that object and explicitly grant access to account C and account D. You're probably dealing with, now this is with one object. If you're probably dealing with like millions of objects, that might not be the best way to do so. So one of the other recommendation is you create a role within account A, give that role permission to do a get object, and then also write a trust policy that allows that role can be assumed by other accounts, such as C and D, and you write a trust policy in C and D. This is the trust policy that you attach to account C and account D with the action of STS assume role, that I can assume account A role. When they assume that role, that's where they get to do a get object on objects that account A does not own. Now, this is a very simple example of cross-account access. If you'd like to go deeper, we have a chalk talk tomorrow where we'll go deeper and do open Q&A on managing cross-account access. Cross-account access. One of the use cases where customers use cross-account access is when they do cross-region replication and they want to maintain two different ownership stacks. So they want the source objects in their primary bucket to be owned by a particular account, and to maintain your DR or business continuity, they do a cross-region replication and the same request change the account ownership to a different account. So this way, they are protecting from threat actors, the two different copies, and maintaining their DR and business continuity. In this particular scenario, you have to ensure that when you write the bucket policies in two different buckets, they have the necessary permissions to perform these actions, the copy operation as well as changing the account ownership. Okay, so we're going to switch gears and talk about encryption in the cloud. Talking about AWS encryption, when your data is in transit, if you're using SDKs or CLI, we ensure that your data is protected with HTTPS and TLS. If you're not using the SDK or CLI and you want your custom applications to upload to S3, we highly recommend that you send it over with SSL or TLS. For encryption at rest, we have three ways to do so. You have server-side encryption with S3 managed keys, which is SSE S3. So Amazon S3 uses AES 256 algorithm, and then we use envelope encryption. So S3 will manage the master keys and the data keys. You should keep in mind that if there is an authorized request and the object comes out of the S3 subsystem, it's going to be decrypted after it leaves the S3 subsystem. Another way to do server-side encryption is with KMS managed keys. So your master keys are maintained in AWS KMS. The data key and the object, the ciphertext, is stored in S3. The third way of doing server-side encryption is where the customer manages the keys. And then you give us the information, and we do the encryption for you. Or you could do it on the client side, where the client or the customer is doing the encrypted object, and all we are doing is just storing the object. So let's talk a little bit about SSE KMS. With SSE KMS, it's an envelope encryption where the customer master key creates a data key, for a unique data key for every object. And then we use the plain text of that data key to encrypt the object and then store it on S3. We throw away the plain text immediately, and then we store the ciphertext of that encrypted data key and the object in S3. When somebody wants to decrypt that object, they will do a get object. We will send the ciphertext data key to KMS. KMS will see that if they have the necessary permissions to call the decrypt API as well, and then send the plain text data key back. We will decrypt the object and send it back. So with KMS, the important thing is your master keys are managed by the KMS service. You can do audit logging, for example, by using AWS CloudTrail, as well as you can have additional usage grants. So you can not only define who gets to do the get object, you can also define in KMS who can call the decrypt API. If I don't have the permissions to call the decrypt API, then I won't get the object because it's going to be encrypted. So I'm getting garbage, basically. So that's where it gives you more granular control on the data that you have. So the benefits are that you have more granular management, you have a centralized access that is auditable with AWS CloudTrail, and then it also gives you better performance for encrypting larger data. So one of the things that we launched last year was a way to have a bucket configuration where you enable default encryption. So if you want to ensure that all objects that go and we store on S3 needs to be encrypted by default, you can use or change the setting or the configuration of the bucket and define the mode, whether it's SSE S3 or SSE KMS. If the put object does not have an encryption header, then it will be encrypted by the mode that you've defined in the bucket configuration. Now, one of the things we've done you should keep in mind is if, say, you have SSE S3 defined as your default configuration mode, and your application has the encryption header to encrypt the object with KMS, then we will honor that request. So even though your default encryption says SSE S3, since your application has asked us to use SSE KMS, we will use SSE KMS, and that object will be encrypted with SSE KMS mode. Okay. So the last topic before I hand over the stage to Chris is about monitoring security. The easiest way to do that is by going to the console, where we will show you if your bucket has public access or not. We actually introduced 3 more statuses that gives you more insight into whether objects can be public, whether your bucket policy, the 4th setting that we talked about in S3 block public access. The similar settings you can check for free by using AWS Trusted Advisor. It's in the console where the free bucket permission checks tell you whether your bucket has open ACLS, it provides read access, write access, or if your policy is granting public access or not. You can also set up managed rules. So if you use AWS config, you can set up a rule. There are 2 rules I've highlighted here, which tells you whether your bucket has public read or public write. Or you can use Amazon Macie. So Amazon Macie uses machine learning in the backend to identify whether there is PII data or not. It not only checks for open buckets, but also shows you a dashboard of where you have PII data and whether you should have them or not. You can also do audit logging. With AWS CloudTrail and S3 server access logs, you can check who's calling those APIs. Those API actions are logged. AWS CloudTrail is a service, whereas S3 server access logs is something that you can use natively within S3. The other thing that you can use is the object encryption, the inventory report, where it shows the encryption status. So some of our customers actually use that report for their compliance mode to see which of their objects have been encrypted and which haven't been. So these are the few capabilities that you have to monitor your security. Now with that, I'm going to hand over the stage to Chris. Chris is going to talk about how they're using S3 in Capital One.
Thank you. Thanks for joining. My name is Chris Schultz. I work at Capital One. I run an engineering team that we don't work on any specific application, but we specialize in IAM, and I get pulled into a lot of S3 problems. So we support all of our developer teams. So who is Capital One? We're really a tech company that happens to be a bank. We started out as a credit card company, and over the years, we've gotten pretty good at using data. We pioneered that in the credit card industry, which seems like old hat now, but we were the first ones to do that in the mid-90s. But here's some stats. So we got about 50,000 associates, 27 billion in revenues, Fortune 100 company. We're also one of the largest banks now. So just you can read that if you'd like, a little bit about who we are. We're more than just a credit card company. Capital One is also, as part of being a technology company, we're cloud first. We really started experimenting with this way back in 2014, which seems like forever ago. And with some of the features that were launched that year at reInvent, we decided to go all in on AWS. So in 2015, we basically said, you know what, we're giving up our data centers, we're moving to the cloud. So we are almost there. We're hoping to shut down the last of our data centers next year. Our reasons are simple. A lot of people think costs or infinite scale, things like that. But really, our primary reason was to give our developers agility to rapidly respond to customer needs in a dynamic marketplace. It's all about getting value out there as fast as we can. Prior to this, Capital One was kind of that centralized IT organization with a lot of processes, and it would take 9 months to a year to get an application from idea to market. Our first production app, granted it was a microservice, went from nothing to in production in about 6 to 8 weeks going into the cloud. So we've really kind of seen the benefits of that agility. So that also underscores the fact that we're trying to decentralize everything. And AWS is enabling us to move away from these complex processes and really put a lot of the power in the hands of the developer. And that's where S3 kind of comes into play. It's really easy to use for our developers. It's got a low footprint. It's a low barrier to entry. And it's got some great logging, as PD just mentioned. But if any of you are in security, any security specialists in here, this really should scare you because you're defining your access to your data right there. And now we're giving it to our developers. So my team has done a lot of work to try to kind of put some guardrails. Still want the developers to have that agility, still let them do their job and not think there's some IT process gunk getting in their way, but try to enable them to do things in a safe way. So the first use I'm going to show you is public ACLs. It's not really how to use them, but it's how to prevent them. And one of the reasons why this feature that PD's talking about today is we really like it. Before the S3 team came out with that, we developed this small print here. It's about 130 lines of IAM syntax that we attached to almost every IAM entity in our environment. So we're over 250 accounts now. I've got maybe 10 to 12,000 interactive humans coming into those 250 accounts doing a variety of things. And this policy gets attached to all of their IAM roles. It gets attached to all their instance profiles and everything. And that blocks the use of ACLs in S3. So you can either flip the switch that PD talked about, or you can sit down and try to write this. The downside of this is it does break a few things like CloudFront, but we don't do that very often, so we centralize that. It also goes a little bit beyond denying public ACLs. One of the things that this does, it also prevents the use of account-specific ACLs. So you can actually set an ACL that says only that account over there can access my object. We don't like that very much either because you can't control what account a developer is putting on that object. So where do you get into the use of ACLs? Well, we have all these developers writing bucket policies, and they're not quite attending these sessions and going through to the depth of understanding what they're doing. They're writing a policy, and it just doesn't work. And they read the documentation a little bit more and go, oh, look, an ACL. Let me put this authenticated user ACL on my object. Oh, look, it suddenly works. Well, they've just opened up that object to everybody else who has access to Amazon, whether it's a Capital One account or somebody else's account, and that gets very dangerous. So something like this blocks that activity. You really need a broad deny statement in your bucket policies, because if all you have is an allow in your bucket policy, and you may only list a couple of users that are allowed to have access to your bucket. If somebody inadvertently sets an ACL on an object, that's now an explicit allow for, say, something like public. And now your bucket policy is rendered almost irrelevant for those objects. There's another conditional that PD touched on in the endpoint. Principal org ID is great to use in your bucket policies because you have to do it in a deny and say deny effectively unless you're in your org, and that'll trump any other allow in an ACL. So remember what PD said. If you have an explicit deny, that trumps any allow. If you don't have that deny, and an explicit allow, like a public ACL comes along, that is what the result is. So we're going to still probably keep this in place, but also use PD's work as well. So I want to talk about how we do cross-account access in one of our use cases. You know, we're a bank. We do this thing called PCI, which in the US is a set of standards on how that credit card issuers have put out there that says, here's how you handle security when it comes to customer data if you're handling credit cards. You have different accounts here that may have different types of data. So account A that you see on the left is what we call fully in scope for PCI data. It might actually have credit card information. It might have other sensitive data that is deemed PCI. And it requires an annual review from an external auditor. That costs money. So you have to go hire somebody. They come in and they run through this set of controls, go, yep, you're good, or no, you failed this. And you have to do that annually. You have to keep up with that. Now, account B is talking to account A. So that means it's still in this PCI world because they're talking to each other. And whenever anything touches PCI, suddenly it becomes PCI. But it doesn't have any PCI data in it. Well, we can actually do an annual review like we're supposed to, but we can use an internal auditor, which costs a lot less money. Still have to adhere to the same controls, but it's not quite as expensive. And then finally, account C, because it's only attached to this account that doesn't have PCI data at the B one in the middle, it's not PCI. So you can relax some of those controls potentially. And it doesn't necessarily need an annual audit, but being a bank, we still do that anyways. So this is setting up our use case. So we've got something in account A that's pulling in data, and maybe it's a data tokenizer. Tokenization is this process where you take something like a credit card account number and you convert it into some other identifier that is meaningless in the marketplace. So if it leaked, it wouldn't mean anything outside of our company. But we could go back and reverse it if we wanted to kind of reverse that account number if we ever have to. But once it's tokenized, it's considered not PCI. And so that data is then written over to the account B. So the tokenizer running an account A with account A credentials is potentially writing to account B. And then maybe you want something, I don't know, maybe some analytics, statement generator running an account C to be able to pull that. So how do you do this the wrong way? So account A writes stuff as account A and account B. And you've got the bucket policy allows puts from the tokenizer and gets from the analytics, but for some reason account C can't do it because you haven't set any ACLs. You haven't done anything to enable that because the object is owned by A. And as PD pointed out, a bucket policy cannot affect access on an object it does not own. And this stumps a lot of people. And this is where sometimes the developer scratches their head and goes, I need an ACL. And they put in a public ACL or something like that, and that would be bad. So how do you do this with an ACL? The tokenizer can set an object ACL that you see here with account C's ID. And the bucket policy still allows that access in from account C. And now account C can read that because there's an ACL on that object that says, yep, account C is allowed to read it. No other account can, but account C can. But it can be risky in some environments. Because like I said before in that previous use case, I can't write an IAM policy that says this developer can only write code that is only allowed to set ACLs for these particular account IDs. So I don't have a backstop. I don't have a control for those developers. We'd actually have to go in and check every object and see that those accounts really are ours. And we can generate a lot of objects in some of our buckets. And that can get very problematic. So the better way to do it is to do assume roles. And when we started doing this 3-4 years ago, a lot of developers who were AWS savvy didn't even understand what assume role was. And this is really important. So you're in account A, you've got your instance profile running in account A, and you actually do an assume role call over with account B, and you grab its credentials. And then you do all your S3 actions into account B with those assumed role credentials. And why do you do that? Because you're doing the put as account B, and now the object is owned by the same account that owns the bucket. And the bucket policy can now affect control of the objects in that bucket. So account C comes along and needs to do its get. It's allowed access. So it's a bit more consistent. The other nice thing about this is if you only ever want your tokenizer to write into that bucket, there's a little trust policy on that S3 writer role. And you can set that trust policy that only allows the tokenizer to assume it, but no one else in account B can. So it gives you a little bit more granular access going into that bucket. So this gives us multiple account access into an S3 bucket. If we were to have accounts D through Z in this model, it's a lot easier because they don't have to worry about the ACLS because all the objects are owned by account B. In the previous model, we're actually writing this grant read ACP with a specific account ID. If you go and add account D, then you have to go back, and maybe you want account D to have access to all those objects. You have to go back and reset all those ACLs to include account D. Oh, and then account E comes along. You've got to go back and do the same thing. And maybe by that time, you're up to billions of objects. That gets very problematic. So our philosophy is we really try to push people away from ACLs in general and really try to get them into the assume role. We've run into some vendor products that don't want to do this. They've been on the marketplace for a while. They try to use ACLs everywhere. We really try to push those vendors to not do that anymore and implement this. I think that's, there we go. And now PDO's come back up for a quick recap.
Just wanted to recap before we open it up for Q&A. Thanks, Chris. A few things that we rehashed today, some of the best practices or pro tips that we discussed. Please follow the principle of least privilege, have granular controls, and don't open up access. Most of your use cases will not require public access, so we recommend turning on the S3 block public access. Within authorization, all decisions start with a deny, and then an explicit deny will override allows. Use default encryption to protect your data further, and then you have different monitoring tools to monitor and audit your data. So we have 7 minutes left, and we'll go on the side, off the stage. If you have questions, please come talk to us. After 7 minutes, we can hang out outside to answer your questions. Again, thank you so much for your time. It's great.